This lesson is about electrolysis. And it's about the relation between chemistry and electricity. Okay, we can use electrolysis. That is a process that's used to separate the elements that are components of a compound. Okay, in electrolysis, we have an electrolysis cell. Any electrolysis cell should contain a tank or a container. This container should have two electrodes. These electrodes are connected through wires to a power supply, a battery or any kind of power supply. And inside this cell, we have the electrolyte. The electrolyte is the material that is or that conducts electricity because it has positive and negative ions. These positive and negative ions can move through the electrolyte, or they are the electrolyte that can move to make a closed circuit. Okay, before taking an example, we have to say that the power supply or the battery has a negative electrode and a positive electrode. The small part here is negative and the longest bar here is the positive. Okay, because of this, all this part we can say that it's positive and this part is negative. So this electrode is positive and this electrode is negative. Okay, we know that different charges attract each other. So because these are free moving ions, so they can move. The negative ion, we call it an anion. The negative ion will move to the positive electrodes. And because the positive electrode attracts the negative ion, which is the anion, we call it anode. So this is anode. The positive ion, which called cation, moves to the negative electrode. So the cation moves to the negative electrode. That's why we call it cathode. So the positive is called anode, the negative is called cathode. Okay. First of all, we will start with molten electrolysis of molten salts. Molten means liquid. As you apply by applying high temperature above the melting point of the salt. Okay, let's start with a sample example. Let's say NaCl. NaCl. Okay, NaCl, if it was solid, it contains ions, but they are not free to move. That's why when it's solid, it's not a conductor. If you apply high temperature on an NaCl above the melting point of NaCl, it will be NaCl liquid. And because it's liquid, it will contain Na plus and Cl minus as free ions. So these free ions can move and conduct electricity. In the electrolysis cell, the one that we have just drawn before, now in the electrolysis cell we have two kinds of ions, Na plus and Cl minus. So Na plus and Cl minus. This is the positive, this is the negative. The Na will move to the negative electrodes, which is the cathode. So at the cathode, because it's negative, it contains a lot of electrons. So Na plus will attract one of these electrons and will give the Na as a metal, as an atom. So it went from being an ion to an atom. So discharge of sodium take place at the cathode. At the anode, the Cl minus, the negative ion, will move to the positive electrode, which is the anode, and because it's negative, it will lose an electron and give the Cl, which is, you know, that it should be, or it is a diatomic molecule. So 2 electrons here and 2 Cl negative over here. Okay, so at the cathode we have Na, and at the anode we have the Cl, the chlorine gas. What happened here is this charge of ions. The positive ion accepted an electron and gave an atom. The negative ion lost electrons and gave atoms, even if it's a diatomic molecule, but it's atoms. Okay? So, at the cathode, is sodium. The product at the cathode is sodium. The product at the anode is chlorine gas. And as you know, if we want to write the overall reaction, let's write it. The overall reaction, okay, we have 2 electrons here, 1 electron here. We have to multiply the whole equation by 2. So we have 2 Na plus, plus 2E minus 2 Na. And this will stay the same, 2Cl minus 2E minus plus Cl2. The overall is, this is a plus, okay, 2Na plus 2Cl minus 2Na plus Cl2. This is the overall reaction. As you can notice, ions, atoms. So this is the purpose of the electrolysis cell, moving from ions to atoms. So this compound gave me the elements of the compound. So I just separated the the elements inside the compound, and instead of being one material, which is the compound, they gave me back the elements of that compound. Now, let's take another example, but now not on molten, now on solutions. Solutions. Aqueous solution, actually. Aqueous solution contains water, and water always has the ions, hydronium ion, H+, and hydroxyl ion, OH-, H+ and OH-. So I will take the same example, the same NaCl, let's say electrolysis of aqueous solution of NaCl. We have some rules here. Why? Okay, for NaCl, if it's in an aqueous solution, I'll just draw the cell. Okay, I have two substances here. I have the NaCl itself, and I have the water because it's aqueous solution. So I have more than one type of each ion, the positive ion more than one type, which are the Na+ and the H+, Na+ from the NaCl, H+ from the H2O. And two types of negative ions, Cl- from NaCl and OH- from H2O. So here we have four types of ions, H+, Na+, OH-, and Cl-. The the OH- and the Cl- will move to the anode, the positive electrode. H+ and Na+ will move to the cathode. So, at the cathode, let's start. At the cathode, we have two types of ions, H+ and Na+. So there is like a competition between H+ and Na+, which one will be reduced. Okay, always the less reactive element, the one that would be reduced. You have the reactivity series for the metals, including the hydrogen. So you know now that the hydrogen is less reactive than sodium. So the hydrogen will, let's say, win the competition and be reduced. Reduction of hydrogen, it will accept electrons and will give the H2, as you know, 2H+ plus 2E- will give the H2. Okay? This is the cathode reaction. So the product at the cathode is the hydrogen gas, is the product at the cathode. Let's go to the anode. At the anode, also we have two types of negative ions, Cl-, OH-. The rule is, look for the halide. If there is a halide is an element from a group 7, okay? You know this. You have to know this. Halide is an element from group 7. Look for a halide. If you found a halide, then the halide will be oxidized. If there is no halide, then the hydroxyl or the hydroxide. So if no halide, then the hydroxide. If there is a halide, then the halide Cl- will be oxidized. So Cl-, also I will write. So here I will have the chlorine gas. So at the cathode I will have the hydrogen gas and at the anode I will have chlorine gas. Okay, I will just say small note. Now I'm talking about concentrated solution. If we have a concentrated solution, then the the number of ions of Na plus and Cl minus are effective to be involved in the reaction. But if the solution is not concentrated, if the solution is a diluted solution, then the Na plus and the Cl minus do not exist in a very high quantities. That's why they will not be involved in the reaction. The only reaction that will happen is for the H plus and the OH minus. Okay, I will say this now. The same example, but with a diluted aqueous solution of NaCl. I will not draw the electrolysis cell again. I will just say that I have the same ions okay. So because it's diluted solution, so I don't have enough ions to be reacted. I don't have enough ions of the electrolyte to be reacted. That's why only the H plus and OH minus that would be involved in the reaction. So at the cathode, I will have the hydrogen and at the anode, I will have the hydroxide, as you know. Plus 4E minus. So the leftover here is the electrolyte. The Na plus and the Cl minus were not involved in the reaction, so these are the leftover. But in this case, H plus was involved in the reaction, Cl minus was involved in the reaction, so the leftover is the Na and OH, which will give NaOH. Here the leftover is an H plus involved in the reaction, OH minus involved in the reaction, so NaCl is the leftover.